Hello and welcome. In this video, we're going to be discussing how to solve a radical equation like the one you see on your screen. Before we begin, let's talk about a couple of background concepts that are going to be important in solving this problem. So if we begin with number 1, I've got a basic equation, 2 plus 3 equals 5. Now suppose that I want to raise both sides to the power of 2. So the question is, how do I do that? So let's offer just a couple of possibilities. So one possibility is that I put both sides in parentheses and raise it to the power of 2. So raise each side to the power of 2. The other possibility is suppose that I just raise each term on both sides to the power of 2. The question is, which one's right? Well, if I look at the first possibility, 2 plus 3, if I combine those first using order of operations, I'm supposed to do what's inside the parentheses first, that's 5. Raised to the second power is going to give me the exact same thing on the right-hand side. If I look at the bottom one, on the other hand, 2 squared is only 4, 3 squared is only 9. If I combine 4 and 9 together, that only gives me 13. That's going to be much different than what I would get if I raised 5 to the second power. So my point is, when I have sums of terms and I want to raise that side to a power, I need to make sure that I put all of those terms in parentheses and I keep my exponent on the outside. I can't just apply that exponent to each term. Okay, let's take a look at number 2. Number 2, I've got the square root of 3 squared. So what does that equal to? Well, let's take a look at it. What does it mean to square something? That just means I'm multiplying something by itself. So in this case, I'm taking the square root of 3 times the square root of 3. If I do that, from what we talked about earlier, I end up with the square root of 3 times 3. Whenever I multiply a square root by another square root, I can combine those under one square root, where the radicand turns out to be the product of each individual guy. Okay, so if I simplify the square root of 3 times 3, well, remember how that works. Square root basically allows me to pull out one factor for every 2 factors that I see. So I've got 2 3's. That means I can pull out one factor of 3, and my answer is just 3. So what I want you to notice is the link between the beginning and the end. What's the shortcut? Well, one way to say it is that squares and square roots kind of like undo each other, and all that's left when it's said and done is just the number underneath. So we're going to use both of these ideas in solving the problem that we saw in number 1. So the first thing that I want to do for number 1 is I want to somehow undo this square root. So my first step is we're going to undo the square root by squaring both sides. Okay, I need to be really careful with how I do this because notice I've got the difference of 2 terms. So when I square this side, just like we saw with the 2 plus 3 equals 5 example, I need to make sure that I put the entire v minus 1 in parentheses and keep my exponent out here. On the other side, I have the square root of 8v minus 23, and I'm squaring that entire square root. Well, on the left-hand side, v minus 1 squared, I need to be careful with how I handle that. So I need to multiply that guy out. So v minus 1 squared is just v minus 1 times v minus 1. On the right-hand side, because all of this is under the square root, the square root and the square are going to undo each other. So all that's left is just 8v minus 23. So on the left-hand side, if I multiply out what I have, I end up with v squared minus 1v. Distribute the minus 1 through, I get another minus 1v, and then negative 1 times negative 1 is plus 1 at the end. On the right-hand side, I get 8v minus 23. If I combine like terms, I've got v squared minus 2v plus 1 equals 8v minus 23. And now I'm done with that first step. So the second step is to solve the equation that's left. So notice in this case I've got a quadratic equation because I have that v squared term there. So if I want to solve this quadratic equation, I want to start by getting all of my terms on one side of the equation. So I'm going to minus 8v from both sides to get rid of those 8v's on the right hand side. I'm also going to add 23 to both sides. If I do that, the left side becomes v squared minus 10v plus 24. On the right hand side, I'm left with 0. And now to solve this quadratic equation, I can either choose to factor, I can use the quadratic formula, or I can use completing the square technique. So this guy does factor. So if you've seen any of my videos on factoring, you can certainly follow that technique here. If you know another technique to factor it, you can also use that as well. But I'm going to skip all of the work because I know that this guy's going to factor into v minus 6 times v minus 4. I know that because I did the work kind of on the side. And then the last step is just to set each of my factors equal to 0 and solve them. So I just want to solve that little mini equation that's left. So if I add 6 to both sides, I get v equals 6 as one possibility. V equals 4 as another possibility. And now I'm not boxing those in because I don't know yet if those are good solutions or not. So with radical equations, I do need to go back and check to make sure that my solutions actually work in the original. Okay, so I've just pulled the original equation over, and now I want to check my solution. So the first one I want to check is v equals 6. So I'm going to take 6 and I'm going to stick it in for my v's. If I do that on the left-hand side, I get 6 minus 1 equals, and really I don't know if they're equal, so I'm going to put a question mark through it for right now. On the other side, I get 8 times 6 minus 23. So if I clean this up, on the left-hand side I get 5. On the right-hand side, I've got the square root of 48 minus 23. If I subtract those numbers, I get 25. And the square root of 25 is actually 5. So my first solution, v equals 6, does check out. So I can box it in. The next one I want to check is v equals 4. So if I check that one, on the left-hand side, if I plug my 4 in for my v's, I'll end up with 4 minus 1 equals, and since I don't know whether they're equal again, I'm going to put a question mark through my equal sign, 8 times 4 minus 23, and 4 minus 1 is 3, equals square root of 32 minus 23. If I subtract those numbers, I get 9. And the square root of 9 is 3. So I get 3 equals 3. That means my other solution is also a good solution. So I get 2 solutions for this particular problem. Sometimes you'll plug a number back in and the left side and the right side won't be equal to each other. That just means you've come up with an extraneous solution. So you need to cross out that candidate solution that you tried and that didn't work. Okay, so here's another example. Pause the video, and after you've given it a shot, retry the video and see if you got the right answer. Okay, so our first step again is we're going to square both sides because we want to get rid of that radical. So if we do that on the left-hand side, we got to be really careful. I can't just distribute the square to each term. I do need to write it out as a multiplication problem. On the right-hand side, we're really lucky because the square and the square root cancel out. So now if we multiply, we get x squared minus 1x minus 1x plus 1. On the other side, we have 7 minus x. If we simplify, x squared minus 2x plus 1 equals 7 minus x. This is a quadratic equation, so I want to get all my terms on one side, so I'm going to add x to both sides. and I'm going to subtract 7 from both sides. So that gives us x squared minus 1x minus 6 equals 0. And then I want to factor, if I can, my left-hand side. I could also use quadratic formula or completing the square technique. But this guy actually does factor pretty nicely, so I get x minus 3 times x plus 2. And then if I set each factor equal to 0 and solve the mini equations that I'm left with, I get candidate solutions of x equals 3 and x equals negative 2. And so now I need to go back to the original and just test to see whether those solutions are valid. Okay, so I just brought our original equation up here. So we're all set to try our first candidate solution. So x equals 3, if we plug it in, we get 3 minus 1 on the left-hand side. On the right-hand side, we get the square root of 7 minus 3. And because I don't know they're equal, I'm going to put a question mark across my equal sign. On the left-hand side, I get 2. On the right-hand side, I get the square root of 4. And 2 does equal the square root of 4. So we are all checked out for that first one. So x equals 3 is a good solution. X equals negative 2. Let's try that one. So on the left-hand side, we get negative 2 minus 1. On the right-hand side, I get the square root of 7 minus negative 2. On the left-hand side, negative 2 minus 1 is negative 3. On the right-hand side, if I combine my terms, I get the square root of 9. And I'm left with negative 3 equals 3. So square root of 9 is positive 3. Those are definitely not equal to each other. That means x equals negative 2 is not a good solution. It's what we call extraneous. And I have to throw it out. So my only solution is x equals 3.